Hello class, and welcome to today's algebra lesson, which is about elimination using addition and subtraction. By the end of today's lesson, you will be able to use addition and subtraction elimination to find solutions to systems of equations. So our second method for solving systems of equations algebraically is called elimination. This means that instead of replacing one of the variables, we are trying to get rid of it. We're going to do this today either by adding or subtracting because we will have a matching coefficient. Once again, the solutions are written as ordered pairs, as these solutions still tell us where these lines would intersect on the graph. So we're going to start by looking at this first problem where I've got 8x plus 3y is equal to 11 and 8x plus 7y is equal to 7. When you are doing elimination, you need to look for the coefficient that is matching. So the number in front of the variable that matches. In this case, it is my x variable with the matching 8 coefficients. In order to eliminate, you have to decide, are we going to add or subtract those coefficients? In this case, 8 plus 8 would give you 16x. That does not make it go away. So I'm going to subtract 8 minus 8x, which is going to eliminate those variables. If I subtract the first pair, I need to subtract the second pair. So 3y minus 7y is going to give me negative 4y. Then I also need to, on the other side of the equal sign, subtract the answers. So 11 minus 7 is going to equal 4. So I've eliminated the x from the equation, and I now can continue to solve for y by dividing by negative 4 on both sides, giving me that y is equal to negative 1. Once again, that is only half of my answer, so I'm going to have to take that negative 1 and plug it back into the top equation or the bottom equation. I'm going to just pick the top. So I've got 8x plus 3 times, instead of y, I know y now equals negative 1. And that whole thing equals 11. So now it's 8x minus 3 is equal to 11. Add the 3 on both sides of the equation to eliminate subtracting 3. And I end up with 8x is equal to 14. And then I'm going to divide both sides by 8. And I'm going to get an answer of, when I do 14 divided by 8, that's not going to come out to a whole number, so I'm going to leave that either as an improper fraction of 7 over 4, or you can change it into a mixed number of 1 and 3/4. Then the last piece, our solution is written as an ordered pair, so I need to write it in an x, comma, y format. So I've got 7/4 for x and negative 1 for y. Go ahead and try this one on your own. In this case, you should be adding these expressions. In order to get rid of the 6y and the negative 6y, I need to add those, which means I'm going to add 4 and 3 to get 7 and add 32 and 3 to get 35. Continue solving for x, plug it back in to get y, gives you the coordinate 5, 2. Looking at this, sometimes my variables are not lined up perfectly to start. So if that's the case, I want to rearrange my equation so that my variables are stacked up. So I'm just going to rearrange this first equation. I'm going to put the 3x in front of the 4y. Positive 3x stays as positive 3x. Positive 4y stays as positive 4y. And it still equals 22. That allows me to match up my variables, so now I can look at my coefficients. I can either subtract to eliminate the x's, so 3 minus 3 to give me 0, or I could add to get rid of the y's, negative 4 plus 4. Personally, I prefer adding when that is possible, so I'm going to add all of my expressions together. So 3x plus 3x is going to give me 6x. Negative 4 plus 4 is going to eliminate it, and that's going to equal then on the other side 14 plus 22, which is 36. I'm going to finish solving my equation by dividing by 6 on both sides, and I find out that x is equal to 6. I now want to plug that back in to one of the equations. I'm just going to use the top equation again. So I have 4y is equal, or excuse me, not equal to, 4y plus 3 times 6 is equal to 22. 3 times 6 gives us 18, so I have 4y plus 18 is equal to 22. Subtracting the 18 from both sides, I find that 4y is equal to 4, and dividing by 4 on both sides gives me that y is equal to 1. Then I need to put it into my coordinate format, which is going to give me my final answer of 6, 1 as the point of intersection for these graphs. Go ahead and try this one on your own. Rearranging that top equation, just flip-flopping the x and the y. Once again, I decided to eliminate the y's. Solved for x, you could have eliminated x first and then solved for y. Either way, your coordinate is going to give you 1, 4 as the point of intersection. For this final example, we are going to take our word problem and turn it into a system that we can solve. So the first sentence says, twice a number increased by 7 times a different number is equal to 33. So the first thing it says is twice a number. So I'm going to make that 2x increased, meaning addition, by 7 times a different number. So that's how I know I want to switch to y, is equal to 33. Then it says if the first number is multiplied by -2, so our first number was x, so now I need that to be multiplied by -2, and then was decreased, so subtraction, by 9 times the second number, so subtracting 9y, the result is now -39. What are the two numbers? So I have my first equation from the first sentence and second equation from the second sentence. Now I look at my variables. The 2 is the one with the similar coefficients. Since it's +2 and -2, I'm going to add all of these expressions. So 2 plus -2 is 0. That's eliminated. 7 plus -9 is -2y. And 33 plus -39 is -6. Then I'm going to go ahead and solve both of my, I'm going to solve my equation by dividing by -2, which is going to give me that y is equal to 3. I'm going to plug that in. I can choose either equation. I'm going to choose the top one. So I've got 2x plus 7 times 3 is equal to 33. So that gives me 2x plus 21 is equal to 33. Subtracting 21 from both sides, I end up with 2x is equal to 12. And then I'm going to divide by 2 on both sides and get that x is equal to 6. So that means for our final answer here, our point of intersection is at 3, 6. Within the context of this problem, I would say the first number, since we want to be specific in a word problem, is 6, and the second number is 3. So we want to specify which number is which. Go ahead and try this one on your own. So we set up our equations. In this case, our x matched. We are going to add, solve for y, plug it back in to find x, and we get 2, -1. So our first number is 2, our second number is -1. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.